Hi, and welcome to this demonstration on clustering a housing dataset using k-means clustering. I am Raghavendra, an expert in AI, ML, and data engineering. First, let's import the libraries. I'm going to set the path to the directory where my datasets are available using os.chdr. Import the data using pd.read_csv. Let's take a look at the dataset. So here we have the ID, date, price, bedrooms, bathrooms, square feet living, square feet, LOT, floors, and so on. There are a lot of parameters about different houses in a particular locality. Let's take a look at the data types. So here we have a mix of integer, float, and object types. So we want to do the clustering on some of the numerical columns like price, bedrooms, bathrooms, and square foot living. So these are the columns which we are going to consider for clustering our data. And I save them in an object called data_num. Let's check the data types. So these are all either float or integer types. Since k-means clustering uses a distance measure, it's always recommended to scale the data. So here I have written a custom function to scale the data. This takes a particular feature as an argument and it's going to return the scaled value for that particular feature. Here, scaling is done by subtracting a particular column from its mean and divides it by its standard deviation. And I'm going to call this method using the apply function. So data_num.apply, I call this method scale for access equal to 0. So this method scale is going to be called for every column or for every feature of the data frame data_num. Let me check the top few records of the scaled data set. So if you can observe, all of the columns will be in a uniform scale. Alternatively, instead of writing a custom method, we can use a built-in method called as standard scaler from scikit-learn.preprocessing. For that, you will have to first instantiate that. And then on this instance, you will have to run fit_transform and pass the data frame comprising of the columns to be scaled. It exactly does the same task as the custom method which we had written earlier. Now let's take a look at this output. So you get the output in the form of an array. If you can check the first value of the price here, you get a value of 0.86, which is exactly the same as what we had got earlier. So either of the techniques will help you scale the data by subtracting every observation by its mean and divides it by the standard deviation. Now let's import k-means from sklearn.cluster. I am going to decide the number of clusters as 3 and set the init parameter to k-means++, which means that my random allocation of centroid for the first iteration is not any random number, but it will be one among the data points for faster convergence. Now I am going to fit the k-means cluster on the scaled data. So let's check the labels. So the first observation is in cluster labeled as 0. The second observation is in cluster labeled as 2. Third observation is in cluster labeled as 0 and so on. Let's take a look at the cluster centers. So these are the cluster centers for each of the 3 clusters. So this is the cluster center for the first cluster. This is the cluster center for the second cluster and so on. Now we just clustered using the value of k as 3. So we do not know whether we have the right number of clusters or not. Let's use the elbow technique to figure out the right number of clusters. So I'm going to run k-means clustering algorithm from range of 1 to 20, that is precisely from 1 to 19. So in each iteration, I'm going to compute the within cluster sum of squares and save them in a list. For different values of k, I'm going to run this k-means clustering, fit the model, and I'm going to compute the within cluster sum of squares. Within cluster sum of squares is obtained through the parameter inertia underscore. So let me execute this. It's a time consuming exercise. So your clustering is not just done once, it is done for different values of k. It is about to take more time because you are repeating the exercise several times. Once done, let's plot a graph between the number of clusters and the WSS values. So along the x-axis, you have the number of clusters, and along the y-axis, you have the WSS values, which is within cluster sum of squares. To start off, you will have a very high within cluster sum of squares, which starts decreasing, and at some point, you will have this WSS value taking a constant. So you have an elbow around 7.5 or 8 to around 13. This is when the WSS value will start decreasing slowly. So any of these values would effectively give you the ideal number of clusters. Another measure to check the performance of the clustering is the silhouette score. So let's compute the silhouette score. Considering we have the elbow at 8, let's calculate the silhouette score for 8 clusters. So let's do that. So first we are going to do the clustering and get the cluster labels for 8 clusters. And then we are going to take the scaled data, the cluster labels, pass it to this method to obtain the silhouette score. This score is usually computed not on the entire data. We create some random samples. So the sample size, I am going to set it, say 10,000, and random state is 200. So I am going to compute the scores. So you get a silhouette score of 0.28. So we do not know whether it's really a great silhouette score. So it could have been even better as well, because we roughly took the number of clusters as 8, which could have been anywhere between 8 to 12 or 13 in the range. Now let's obtain the silhouette scores for different values of k. In every iteration, we cluster the data. We are going to get this silhouette score for different values of k. So here are the different silhouette scores for different values of k. If you observe, the silhouette score for k is equal to 8 is the highest, which is the maximum possible what we can get. Now let's check on the cluster profiles. So I have written a custom code in a separate .py file to get the cluster profiles. Based on the z scores. So I'm going to pass the copy of the dataset and the k-means instance to this particular function. I'm going to extract the labels after clustering for each observation here. For every cluster, I compute the mean and subtract it by the global mean, which is nothing but the mean of all the data points, and I'm going to divide this by the standard deviation. So that's my z-score value. And then I'm also going to get the number of observations in each cluster. So this is in an external file which we will have to import. So cluster profiles is a function which is there inside a file called as cluster_profile.py. I'm going to import that first. Then I'm going to obtain the profiles for 8 clusters. And I'm going to get the instance of k-means, get the cluster profiles for that. I'm going to pass the copy of the original dataset and the instance of k-means to the function get_z profiles. So here are the z-score values for each of the features which we have considered for clustering. And the last column is the total number of observations in each of the clusters. The first cluster has 151 observation, the next has 4318 observations, and the next has 1075 observations, and so on. In cluster labeled as 0, for the price column, the value of 6.5 means that the price in this cluster is 6.5 standard deviations above the mean, which means that these are high-priced flats with high-priced bedrooms. The bedrooms are 1.28 standard deviations above the mean. The bathrooms are 2.69 standard deviations above the mean. So, square foot living is as well as high, which is 3.76 standard deviations above the mean. So, these are probably the high-priced, premium-sized and premium quality flats. Now, let's take a look at the cluster labeled as 2. Here, you have the price as 0.28 standard deviations from the mean. And the bedrooms are pretty large over here, that is 2.131 standard deviations above the mean. And the bathrooms and square foot living are as well large. If we closely observe, these are not so expensive flats. I can say they are reasonable flats with high-sized bedrooms, much higher than the ones in cluster labeled as 0. So, in this way, you will be able to arrive at inferences by looking at the cluster profiles using the z-scores. In this video, you have learned how to cluster the data points using k-means clustering, how to choose the best value of k using the elbow technique and using the Celoid scores, how to obtain the cluster profiles using z-scores and obtain inferences about the clusters from them. Thank you for watching this video.